Welcome back to The Explainer. I am so excited you're here today because we are going to break down one of the biggest buzzwords in the world right now. You guessed it, machine learning. Now, if you've ever felt kind of intimidated by this concept, maybe assuming it requires a PhD in advanced mathematics or coding to even grasp it, well, you are in the exact right place. Today, we are completely demystifying machine learning using simple, everyday concepts. No confusing code, no complicated math, just clear, easy to understand explanations. Let's get right into it.
Okay, let's dive into this. Have you ever wondered how everyday technology magically seems to, well, read your mind? I mean, how does Netflix seem to know exactly what movie is going to hook your attention on a Friday night? Or how does your smartphone recognize your face out of literally millions of others? It honestly feels like magic, but it's not. At its core, it's simply a computer learning from your past choices. And that brings us to the fundamental definition we really need to understand. Machine learning is a subdomain of computer science, and its whole focus is on helping a computer learn from data without a programmer explicitly telling it exactly what to do. You see, back in the day, if we wanted a computer to do a task, a human literally had to sit down and write out explicit step-by-step instructions. Do this, then do that. Machine learning completely bypasses the need for all that explicit programming. And this brilliantly illustrates the whole paradigm shift. It's a real game changer. Think about traditional programming kind of like a strict recipe. You give the computer the rules and the data, and boom, it spits out the answers. But machine learning flips this entirely on its head. Instead, we give the computer the answers and the data, and we ask the machine, hey, you figure out the rules. The machine is actually finding the hidden patterns all by itself. Section 1. Supervised learning and labeled data. So to understand exactly how the machine finds these rules, we gotta look at the different ways we can train it. Let's start with supervised learning. Imagine a guy named Paul, right? Paul loves listening to music. When evaluating his music tastes, a machine looks at two specific things: features and labels. Think of features as the inputs, the actual ingredients of the data. For a song, the features might be its tempo, its intensity, or its genre. The label, on the other hand, is the output. It's the answer we want. In this case, the label is super simple. Paul likes the song or Paul dislikes the song. In supervised learning, we literally feed the machine past examples where we already know both the features and the labels, so it can actually learn the relationship between them. What's really interesting about this is how cleanly it maps to physical objects. Imagine someone dumps a massive pile of 1,000,000 coins from different countries right in front of you. We want to train a system to sort them. The weight of the coin, say 3 grams or 7 grams, well, that's our input feature. The actual currency, whether it's a rupee, a euro, or a dirham, that is our output label. Once we feed this label data into the model, the magic happens. The next time we hand the machine a total mystery coin that weighs exactly 3 grams, it instantly applies the rule it learned and predicts, that's a 1 rupee coin. Section 2. Unsupervised and reinforcement learning. But what happens when we step into the unknown? What if we don't have all our data neatly labeled with the answers ahead of time? Well, in unsupervised learning, the machine is flying solo without any labels whatsoever. Imagine feeding a computer a massive data set of cricket players, but it only contains raw stats like runs scored and wickets taken. We don't tell the machine who is a batsman and who is a bowler. But the machine looks at the data and automatically begins clustering the players based on hidden patterns. It notices, hey, one group scores lots of runs but takes almost no wickets, and this other group takes lots of wickets but scores few runs. It separates the batsmen from the bowlers completely on its own. It's discovering structure in raw, unlabeled data. And then we have reinforcement learning, which honestly works a whole lot like training a dog. It's this continuous, interactive loop of rewards and penalties. Picture this. You show the system an image. The machine guesses it's a cat. You, the human, provide negative feedback and say, no way, that's a dog. The machine registers that penalty, adjusts its internal rules, and learns from the feedback. That way, next time it sees a similar image, it guesses correctly so it can earn a reward. Section 3. The deep learning difference. Let's see how all of this builds into something even more powerful. You have absolutely heard the term deep learning thrown around, usually as a more advanced form of artificial intelligence. But deep learning is actually just a specific subset of machine learning powered by artificial neural networks. So what makes it deep? The answer is surprisingly simple. 3. Yep, the number 3. A neural network is simply a series of layers that process data. You have an input layer, an output layer, and some layers in the middle. And here is the punchline. A neural network is only officially considered a deep learning network if it consists of more than 3 layers. That is literally the distinction.
So the absolutely crucial point here is what those extra layers actually allow the system to do. You see, classical machine learning relies heavily on human experts to define the features. If we wanted a traditional machine learning model to recognize fast food, a human would have to manually label specific characteristics, like the type of bread or the cheese, just to help the machine tell the difference between a pizza, a burger, and a taco. But deep learning? It doesn't need that human intervention. It can ingest totally unstructured data in its rawest form. We're talking just the raw pixels of a pizza image, and it automatically determines the distinct features all on its own. And the reason this is so wildly fascinating is because these models aren't just theoretical. They're literally running your everyday life right now. When you pull up the Uber app and see a surge price, that is a machine learning model predicting high demand based on live weather and local traffic patterns. When your email inbox magically catches a scam message, that's a binary classification model filtering out the spam. And when your social media feed just keeps you scrolling, yep, that's a model predicting exactly what content you will like based on your past behavior. It is everywhere. We live in an era where humongous amounts of data are generated every single minute, and that gives these machines incredible power to learn, adapt, and predict the future way faster than any human ever could. We have gone from basic, rule-following programming to machines that can cluster, classify, and deep learn from the very fabric of our digital lives. So, I want to leave you with a thought today. Knowing that we can train computers to find these hidden patterns and solve incredible problems just by feeding them the right data. If you could teach a machine to do absolutely anything, what would you train it to do? Keep exploring, keep questioning, and I'll catch you in the next explainer.